Okay, here's a linear motion question. Given a velocity and a position at t equals 2. And there's 3 questions we're going to answer. We're going to make quick work of this. We're going to use a calculator for this. The first question is find the position. So the position that a particle ends up at is you have to figure out where it starts, that should be given, and the net distance it goes through. So in this particular problem, it starts at position 0 when t equals 2, according to this. So we're starting at 0. You don't have to write that obviously, but if it were anything other than 0, you would. And we had to add its net distance to its starting position from the time we're starting, t equals 2, to the time we're trying to get to, t equals 4. And you integrate the velocity there. So this integral of velocity is the net distance. So I typed this on my calculator already. We're going to calculate the integral from 2 to 4. And we get a net distance of 2. So this is 0 plus 2, which equals 2. So we ended up at position 2. Now, just keep in mind here, it's very important to realize where we started. So if this question said at x of 2, we were at position negative 16, well, then our position would have been at negative 16 plus 2, which is negative 14. So the total distance traveled, now this has where we started has no bearing on total distance. We just figure out how far we traveled, including changes in direction. So what does that is the integral of the absolute value of the velocity. Now, it doesn't give us any time intervals on this question, but it does tell us up here that we're going from t equals 0 to 5. So what I'm going to do is just integrate the velocity, the absolute value of the velocity, or the speed, from 0 to 5. I'm going to do that in the calculator. Now, if I didn't have a calculator, I have to figure out where this is negative, which is from 1 to 3, because I know the intercepts. I know it's a parabola, it opens up. And that part of the integral I'd have to take the opposite of. But that's for a different video. So to integrate the absolute value, you can just find the absolute value and type it again. I'm going to turn this graph off. And then on this graph, I'm just going to find my absolute value key and then type in alpha trace to get y1, so I don't have to type it in again. So now it's going to graph the absolute value of what I have in y1. And here it is. It makes sense because the parabola used to come down like this, but the negative part, it flipped up to be positive. So now it's very simple. Second calc 7, integral from 0 to 5, and I get 27.99, which is 28. So the last question is find the average velocity. Oh, good. This is easy. Average velocity would be the average value of the velocity, obviously. And we have a formula for average value of a function. It's just the integral of the function divided by the length of the interval. So we have 1 over 5 minus 0 times the integral from 0 to 5 of the velocity. That would give you the average velocity. And that's easy. We have it in our calculator already. So to find my calculator, I lost it. So now I'm going to turn the velocity equation back on. And I'm just going to turn this one off. So now it graphs the regular velocity. I'm going to integrate that again from 0 to 5. This should be lower because you're going to have this negative part, lower than the previous one, I mean. So that's 20. That's a nice number because we're dividing this by 5. So this is going to be 20 over 5, which is 4. There you go.